Okay, let us now see to calculate the rigidity modulus using static torsion method. So, just previous to your Young's modulus experiment, here also we have two knife edges here. Okay, and this is the pendulum torsional. This I have here this flywheel was moving along the vertical axle. Here this is the rotating about this axis. This is the difference. So the torque acting on that will be calculated, the velocity with which it is moving, and accordingly calculate the rigidity modulus. Rigidity modulus is ratio of volume stress by volume strain. Shear stress by shear strain is surface. This is volume. So now what you have to do here again is you have different materials, copper, aluminium, brass and iron. You can move it in the clockwise direction as well as anti-clockwise direction. So let me choose copper. Okay. Choose material of the rod that you are using. This is the rod. And then if you choose, let us say, aluminium is change to brass. It's not brass. Then iron, it's iron. What all you have? Aluminium, brass and iron. Copper, this is copper. This is aluminium. Brass, this looks like a brass. The last one is iron. And then position is important. You should choose it in such a way that the scale is seen. Distance between the scale and mirror. So that you keep it at a convenient place where you can see. Then yeah, little time. So accordingly, position is very important. Adjust it in such a way that you will be able to see the scale properly. This is the distance. And then mass can be varied. See, this is the mass of the weight. Can you see it's changing? Yes? Adjust the radius of the metal rod. Radius of the metal rod 3.3 mm. This is 3.8. 4.4. Accordingly, it will change. Yes. And then the radius of the pulley 5 centimeters. Let me keep 8.5 centimeters. The radius is increased. So choose them as convenient values. So I think you can do it for different distances conveniently. Distance between the scale and the mirror, it's changing. Can you see? It's changing. Accordingly, position also has to be changed. If you change this also has to be changed so that you can see the scale properly. Now, see. So if you change this distance, the telescope has to be properly fixed, not clear still. So you have to see where it is clearly seen and fix your telescope for that position. It should be closer. Somewhere here only you will get a better one. Reduce it. Yeah, this is better. Closer, better closer one. This also, and just in such a way that so it's not clear here. So you should come closer to this. Not able to reach there, isn't it? Take it closer. Take this also closer. Now adjust the position. 101 centimeters. Two ends should reach here. That is the idea. Right here. These two should coincide. Then only you will be able to see it properly. And then this, find out, show the result. It will show you rigidity modulus of copper rod, 40 point something you are getting. And change this to a brown 40. Raise it. Do all this and show the result. 45. So like this you will be using, and you can show these values here in this determination or rigidity modulus of the given rod. So you can attach the mass clockwise and anti-clockwise. Radius of the rod, you just do 3, 4, 5, 3 readings. Clockwise, this is clockwise, anti-clockwise. You can do it for copper, and then I have shown it for the clockwise copper for 3 readings, 3, 4, 5, and repeat it for anti-clockwise. So how do you get this anti-clockwise thing? Here you should choose it here, anti-clockwise. So now what is happening now? This is the position. This is the correct position. So choose anti-clockwise here. Okay, and this is the correct position of the telescope. And then for different distances, radius 3, 5, 6 and 7. 6 and 7. Radius is increased, and then show the result. You can reset it, do all these different values 6, 7 like that, show the result. So this is how you will be calculating it for different positions.